All right, here we are on to homework number 2, truth tables. So, to let you know, if truth tables feel difficult, they shouldn't. And so it's coming from the fact that truth tables are, it's a study of logic, so everything you do should feel logical. So let's run through some of these problems. Proposition, I'll let you search for the definitions within the lecture notes. Okay, so when you're doing a truth table, it always starts off like this. You have one column for one proposition, another column for another proposition. So P and Q are representing two separate propositions, and we are linking P and Q together with this and statement. So for an and statement to be true, so essentially we're going through this column and we want to fill out true or false for each entry. And whether it's true or false depends upon the connector and what the original propositions were. So we are linking P and Q together with an and statement. So the logical connectors are and, or, and then the last one is if, then, also known as a conditional. So we're working with P and Q. So this begs the question, well, when is an and statement true and when is an and statement false? Well, an and statement is true if both pieces are true. It's very similar to the way we speak. If you say something, I don't know, I'm failing to come up with a good analogy. The thing to focus on is an and statement is true if both pieces of that and statement are true. Otherwise, it's false, which makes sense. If you're saying proposition A and proposition B are true, that implies that both A and B are true. So, as you might anticipate, this first entry, P and Q, is true because P is true and Q is true. Again, for an and statement to be true, both pieces of that and statement must be true. So, in this second row, P is true, Q is false, so the and statement is false. And that's because both pieces of that and statement must be true in order for the and statement to be true. So think of it as the presidential election. Two things have to be true in order for you to be allowed to run for president. You have to be a natural born citizen and you have to be over 35. Both of those have to be true in order for you to run for president. If either one of those is false, if you're not over 35 or you're not a natural born citizen of the United States, you can't run for president. So both pieces have to be true for an and statement to be true. The third row, P is false, Q is true, so the and statement is false. Again, an and statement is only true when both pieces are true. Otherwise, it's false. An and statement is true if and only if both pieces of that and statement are true. All right, here's another one for an and statement. Again, recall the fact that an and statement is true only when both pieces of the and statement is true, or are true. So that would be the top row here. Everything else would be false because you at least have one false in each row. This first row is the only row in which both pieces are true. Okay, So this begs the question, how do you handle three propositions, Q, R, and S? Before we were only doing two. Well, the idea is the same. For an and statement to be true, all pieces of that and statement must be true. So recognize Q is true, R is true, S is true. So the and statement of Q and R and S is true. Recognize an and statement is only true if all pieces are true. In the second row, Q and R are both true. However, S is false. Because S is false, the and statement of Q and R and S is false. Again, an and statement is only true when all the pieces are true. Otherwise, it's false. So, I think you get hopefully you get the gist, what's going on here. Not R and R. Okay, so if R is true, that implies not R is false. So this not simply flips true to false. So R is true, so not R must be false. Right? The not is taking the negation or the opposite. Now we're connecting not R and R with this and connector. So not R is false, where R is true. Well, an and statement is only true if both pieces are true. Well, recognize R is true, however, not R is false. So we have a false and a true. So it's false because an and statement is only true if all pieces of that and statement are true. We can follow this one through. R is false, so not R is the opposite of R. So R is false, so not R must be true. Connecting not R and R, well, R is false, so our and statement is false. And that's because for an and statement to be true, both pieces of that and statement have to be true. All right. The following propositions have the form P and Q, state P and Q, and give their truth values. Then determine whether the entire proposition is true or false and explain why. Carrots are vegetables and radishes are fruit. So the first proposition, P, right, we're following this structure, P and Q. Here's our and statement. So P must be carrots are vegetables. Identify Q. Choose the correct answer below. We'll recognize carrots are vegetables is the first proposition. Q is the second proposition within our and statement. Q is the second proposition of this statement. The second proposition is radishes are fruit. Right, we're following this structure. P and Q. P is the first proposition, carrots are vegetables. Q is the second proposition, radishes are fruit. What is the truth value of P? Well, carrots are vegetables, so that would be true. Ah, shucks, come on. What is the truth value of Q? Well, Q is the second proposition, radishes are fruit. Radishes are not fruit, so that would be false. The entire proposition, is it true or false? So when they say the entire proposition, they're talking about P and Q. Well, an and proposition, an and connector, is only true if both P and Q are true. We stated Q is false, so the entire proposition is false because P is true and Q is false. It's true because P is true and Q is false. Oh, the entire proposition is false. The entire proposition is false because P is true and Q is false. Be sure to read carefully. All right, this next one is a similar song and dance. Again, using the and connector for two separate propositions. In this case, carrots are vegetables and bananas are fruit. I'll let you try this one on your own. Number 8, similar, yet again. All right. So this is similar, but instead of statements like carrots are vegetables, we're using statements like 3 plus 3 equals 6. So the first proposition would be this 3 plus 3 equals 6. The second proposition would be this 8 times 6 equals 96. The first proposition, true or false, well, 3 plus 3 is definitely 6. The second proposition, 8 times 6. 8 times 6 does not equal 96, so that is false. Is that it? There we go. Is the statement 3 plus 3 equals 6 and 8 by 6 equals 96 true or false? Well, it's false because this second claim, or this second proposition, is false. And an and statement is only true if both pieces of that and statement are true. So, let's read this carefully. The statement is false because first proposition is false. No, so the statement is false because the first proposition is true, second proposition is false. Yes, the statement is false because the first proposition is true and the second proposition is false. Okay, so now we're moving into the OR connector. In order for an OR connector to be true, one or the other has to be true, right? So for an AND statement to be true, we required both pieces to be true. For an OR connector to be true, we only require one to be true, right? It's an OR statement, one or the other. So R and S, they're both true, so R or S is true, because at least one is true. R is true, S is false, so R or S is true, right? For an OR connector to be true, one or the other has to be true. In this case, R was true, S was false. Well, R being true is good enough for the OR statement to be true. In the third row, F, so R is false, S is true, so the OR connector is true. Again, an OR connector says at least one or the other has to be true for the OR statement to be true. So, the only way for an OR statement to be false is if both pieces are false. It's kind of the complementary idea to the AND connector. AND connector is true only if both are true. An OR connector is false only if both are false. Again, the AND and the OR follow directly from how we normally speak. So, similar type of idea, an OR connector is true if at least one of the pieces within that OR statement is true. So Q, P, and R are all true, so the OR statement is true. Here we have at least one true, so the OR statement is true. Again, at least one true, so the OR statement is true. So keep in mind, the only way for an OR statement to be false is if all the pieces are false. So recognize in all of these rows we have at least one true popping up. It's only when all three are false that your or statement will be false. Again, an and statement is true if all the pieces are true. An or statement is false only if all the pieces are false. I'll let you try out the nots with the ors. Keep in mind, an or connector is true if at least one is true. So you should already know what this answer is going to be, right? Not Q or Q. Well, an or statement is true if at least one of these pieces is true. So an or statement is true if not Q is true or Q is true. Well, look over here, Q is true, so that or statement is going to be true. So I guess we'll do this one together. Q is true, so not Q is false. Remember, the not simply toggles true to false and false to true. And also recall that the or connector is true if at least one of the pieces is true. Okay, so a similar type of idea here from before, except before we were doing P and Q, here we are doing P or Q. So first identify the first proposition from this statement. Strawberries are vegetables or strawberries are fruit. Well, identify P. P is the first proposition, which is strawberries are vegetables. The second proposition in this case is going to be the strawberries are fruit. Similar idea here from before, except instead of the and connector, we are using the or connector. So let's go through this one together. 10 times 9 equals 180, or 5 plus 8 equals 12. The first proposition is, well, 10 by 9 is 180. The second proposition is 5 plus 8 equals 12. First proposition, is it true or false? Well, that's definitely false. 9 times 10 is 90, not 180. So the proposition is false. Oop, I don't want to do that. The second proposition, 5 plus 8 equals 12. Is that true or false? Well, that's false. 5 plus 8 is 13. So, recognize both propositions are false. We're using an or connector. Hence, the statement is false because the first proposition is false and the second proposition is false. Right? That's the only way an or connector can be false, is if both pieces of that or connector are false. All right, the big bad conditional. So, if Q then R. So, a conditional statement or an if-then statement is always true except for one condition. There's only one condition where you will get a false implication. So if your hypothesis is true and your conclusion is true, the implication is true. If your hypothesis is true and your conclusion is false, you get a false implication or a false conditional. This type of connector goes by several different names: implication, conditional, if-then, to name 3 of them. So recognize this is the only condition where you will get a false implication, where you get true hypothesis, false conclusion. So the hypothesis is the first part. The conclusion is the last part, right? You start with a hypothesis, you end with a conclusion. You end with a conclusion should not be a new idea, or hopefully is not a new idea. So the conclusion is the ending part, right? So if Q, then P, or I'm sorry, if Q, then R. R is the conclusion because it's at the end of the statement. You only get a false conditional when you have a true hypothesis and a false conclusion. So if true, then false is a false implication. So everything else is true. So, and to speak more about this conditional statement, it's really driving at the idea of supersets and subsets. So consider the statement, if it is a rose, then it is a flower, right? A rose is a subset of types of flowers. So it's establishing a relationship between sets, which is where we're going next. So if Q, then R. You could also say Q implies R. So if it's a rose, it implies it's a flower. Again, this conditional is only false under this set of criterion. When your hypothesis is true, your conclusion is false, gives you a false implication. Otherwise, it's true. I guess we'll final check. Yeah. All right. So if eagles can fly, then eagles are birds. So the hypothesis is eagles can fly, right? Because the hypothesis is the first part. It's the part that immediately follows if eagles can fly. So eagles can fly is your hypothesis. Hypothesis is the first part. Conclusion is the second part. So the hypothesis is eagles can fly, which is true, last time I checked. The conclusion is eagles are birds, right? The conclusion is the second half of, or the piece that follows after then. Eagles are birds would be the conclusion. Eagles are birds, so that would be true. So the entire proposition, is it true or false? Well, a conditional proposition is only false when your hypothesis is true and the conclusion is false. So this would be true. Because the only way it's false is if I have a true hypothesis and a false conclusion. Here I have a true hypothesis and a true conclusion, so my entire proposition is true. All right, and I'll let you take a stab at this last one. That is truth tables. Thank you for listening.